Thanks for having me, everyone. And I'm looking forward to seeing what you think of a lot of the work that I've been doing in this space. I always like to call it the witchcraft that I'm involved in, but I feel that it's important, especially as we're moving into, this world where there's all these different grand challenges that we have to deal with, that we start to see all the different disciplines that are working on this aspect and how we can bring them together. And that's sort of the binding theme of a lot of the work that I'm going to be showing today as well. So, Peter, you gave a splendid introduction. I thought I'd put a few words about what I do and sort of where my research is positioned, and just to give you a bit of an insight. So, civil engineer by training, my PhD then expanded into urban planning. That's what gave rise to Urban Beats, this crazy model. You'll see parts of it in the presentation, but I'll be showing a few different models as well that we've been looking at. Then during my postdoc, I delved into various aspects like urban climatology, so working with microclimate a lot more, and I got involved in social sciences firsthand. So I had some experience during my PhD working with social scientists. But I like to say my inner geek is all about modeling and geospatial information sciences, so working with spatial data and trying to model cities. But ultimately, if you look at the research, if I had to present it in a visual way, you would get this Venn diagram that you have on the right-hand side, where my research really is at the intersection of integrated urban water management, urban livability and ecology, and all within a city that is constantly evolving and needs to transition towards more sustainable solutions. But this is where blue-green systems comes in, this idea of nature-based solutions, using nature in cities. Here's some visuals to sort of illustrate that, how we can utilize the effects that natural systems can provide to create more livable cities. This concept has been around for a long time. It's nothing new, actually. If we go back to the early 1900s, we actually had this incredible planner. His name was Ebenezer Howard. He first published this garden city idea, and that was linking cities and the countryside environments together and emphasizing the role of nature, in particular green belts, to help this linkage. And biomimicry, this idea of mimicking biological processes, is nothing new. It's a long-standing concept which we use in a lot of different disciplines, whether it's in electrical circuits or in machine learning or in urban planning. It's become much more of a focus nowadays because we're starting to learn and understand that if we try to do things the way nature does, we can often achieve more sustainable solutions that are quite cost effective. Even Michael Polwin, famous architect who I think worked on the Eden project in the UK, his famous rehabilitation project that took an abandoned quarry or abandoned mine and turned it into this beautiful sustainable development. He talked about this potential of achieving huge savings in resources and energy use if we can just learn to do things the way nature does. This is evident in urban water management when we look at how our urban water systems have evolved. When we began, it was all about getting a secure water supply. Cities were built along major rivers and waterways and lakes because they provided fresh sources of drinking water. And as we started developing the cities, we started looking at sanitation, the needs to bring our wastewater somewhere, cleanse it, and discharge it safely. As rainfall became a serious issue in much larger cities, the incidence of floods made us aware of the need to actually build drainage systems and help deal with that water. And that mindset then took a shift when we started to realize, well, this linear management is actually not going to help us because it's actually degrading our environment, whether it's causing pollution in our streams or whether it's actually causing geomorphic changes in our receiving waterways. And with this increasing environmental knowledge, this sociopolitical awareness, but also with the advancements in technologies and how we deliver urban water services, we've started to evolve the way we look at urban water management from a linear fashion to a more cyclic fashion. And so we're now moving into new paradigms of urban water management. This famous diagram was actually adapted from a paper published by Rebecca Brown in 2008, which showed the different stages of evolutions and concepts for urban water management up to what they know as the water-sensitive cities. But we're definitely moving beyond these concepts now with the involvement of more ecosystem services in our cities. And we're transitioning towards what we would call the blue-green city. And what that sort of means and represents and my vision of it, I will show in the coming slides. But blue-green systems or blue-green infrastructure has been known by many names, and this is it's no coincidence that this name has also evolved along with the different concepts over the years. We used to call them sustainable drainage systems back in the early 2000s, late 90s, early 2000s. In Australia, the term water-sensitive urban design emerged in the early 2000s and became much more mainstream, and is still probably the mainstream term, especially when I talk to people there. That is the main term and the main concept that they use to describe this kind of water management and nature-based approach. But we are starting to become much more aware of this idea of a blue-green system, calling it based on the names, using water and nature to harness the potential ecosystem services that they can provide to our city, and to create more livable, sustainable, adaptive cities. And this is definitely necessary given that we're dealing with a growing list of challenges, be it climate change, population growth, urbanization, that's causing biodiversity losses. We have experienced the pandemic, which I know has been questioning how we actually plan cities in the future. But we've got the blue-green city concept. And what is it really? It's this idea of making cities greener, designing for sustainability, efficiency, adaptability, and resilience. So being proactive rather than reactive. We've typically faced a challenge and then we've tried to find a solution as a sort of damage control. This is a sort of interesting term I saw used in the literature, which I thought was quite inspiring, because it really shows that the mentality is shifting from this reactive to a more proactive approach. Being strategic, there's this notion of strategy behind it, where we really start to think about not just putting in solutions because they're nice to have, they do their job, they serve a particular purpose. So whether it's flood retention or putting in trees to cool cities. The blue-green, the reason I like to use this term compared to, I guess, nature-based solutions, I see nature-based solutions as a much larger concept beyond the city. But I like the term blue and green because it talks about the need for nature and using nature and vegetation and the power of the vegetation to deliver all these different services, but it doesn't operate on its own. We need to sustain nature, and water can play a very strong role in sustaining that and even driving some of the processes that these systems undergo. And it's about holistic planning and management of water in support of these kinds of solutions that we build. The reliance in a blue-green city is on blue-green systems or infrastructure, and this does not only refer to physical things we built. Doesn't just refer to the technologies we've been researching, whether it's a constructed wetland, a porous pavement, a rainwater harvesting system. It also refers to practices, mindsets, policies, and also just generally the spatial planning of the environment, the shaping of the urban form. Most importantly, all of this has to be delivered under the concept of adaptive management, being able to anticipate and to have, I guess, backup plans in place, checks and balances to ensure that we can maintain the sustainability of our cities going forward into the future, especially given all the uncertainties around climate, population growth, and urbanization. A lot of this concept has been inspired by things like the water-sensitive city. It builds upon that, in fact. But also other concepts like the circular economy. If you look at the EU cost action, circular city, there are a lot of similarities in circular cities to blue-green cities. And I think the term really took off in 2017 with the publication from Climate KIC called the Blue-Green Dream. For those interested, you can go search up Climate KIC Blue-Green Dream on Google and you'll find the report. And I think it's a very nice summary of what a blue-green system and a blue-green city entails. If I had to visualize what that really means, If we take Zurich, for example, and we look at its current state, you can see it's quite urbanized. You've got buildings everywhere, and you have a few pocket spaces. How would we create a blue-green city out of this, or what would it look like? And I think it requires the combination of different strategies from these strategies are in place over, say 30 to 50 years, but it's this continuous planning and adaptation of the city to become what we think is a blue-green city. And as I mentioned before, it's not just technologies. It's changing of the space. It's implementing policies. So I like to look at it at three levels. The widgets that we build, that we can engineer, the spatial planning, and then the regulations that govern them. So for example, you could have green space and connectivity provisions. You'll see in the later slides why connectivity is important and quite a strong theme throughout the work I do. But you can also have things like restrictions to zoning to control the encroachment of urbanization on forests and natural land. You can control urban densities to ensure that we don't have major sealing of surfaces and therefore higher incidence of floods. When we then look at changing the actual space, using urban greenways, making corridors that are green across streets or connecting parks together with the use of greenery can provide valuable areas for floodwaters to flow, for example. Waterfront green space can provide places for people to go to on a hot day when the urban area heats up from the sun and the heat gets trapped without anywhere to go. We can also think of the ecological aspects, such as the littoral zones or the riparian zones along rivers and lakes, and restoring them to ensure that we've got biodiversity happening in those regions and refuge for animals and species. At the smaller scale, we would be looking at pocket parks, or we could also be looking at local harvesting systems to ensure that we are using water in a sustainable way, with the added benefit that we're reducing the amount of runoff from our urban environment. And green roofs, facades, they're a pretty common little widget in technology that can help provide some very nice visuals for the urban dwellers and the urban residents. So a lot of these concepts, they exist and they've been tried and tested in many different forms and shapes in different cities. But the key is, how do we bring them together? And that's sort of where my research is moving towards. I've worked traditionally in the stormwater management space, and I've looked at the technological side of things. The UrbanBeats model, I presented this a few years ago to you guys, looks at trying to figure out where to put these systems based on catchment hydrology to try and meet stormwater management targets, whether it's for water quality, runoff volume control, or potable water substitution. This is just an example of a local development that we modeled using the UrbanBeats model, and we tested against a real design. And this is a fairly straightforward approach where you can test a number of different scenarios to come up with a solution that will meet your criteria. But it is a very technological based approach, and it's quite stormwater focused, nevertheless quite important. I've since then looked at a lot of other aspects in the stormwater management space, including more things about water quantity and quality, working together with my colleagues in Australia to try and understand how the water quality varies over space and time in urban catchments, and how different interventions like the removal of septic systems can actually, and the sewage, the rollout of broader sewage and drainage systems can actually improve water quality over time. I've looked into trying to link this with stormwater harvesting. Removing water from the system by harvesting it and then using it for other uses can also have certain benefits to runoff control and water quality control. And we've tried to quantify how much that benefit actually is. We've looked into urban flooding. There's been this long argument that these systems, whilst they're designed for 3-month storms, may not be able to mitigate larger floods, but they can potentially mitigate a lot of the nuisance events where you have smaller rains that can cause surcharges of drainage systems. And so we've looked at some of the interactions of rainwater harvesting with flood mitigation, with some interesting results that show that there is potential, but of course it requires a much larger rollout of these systems and a much larger adoption. And finally, also looking on the future climate side, we've looked at the resilience of these systems to future climates, looking at an individual design of a bioretention or a wetland, and testing this against future projected rainfalls from downscaled climate models. We actually took an ensemble of climate models and ran it through one of the state-of-the-art models in Melbourne to try and see, well, how would the design change, or how would the design be affected? And we found that the performance itself of these systems can be quite resilient depending on the kinds of future conditions you're dealing with. But there are going to be issues to be aware of, such as the amount of spillage from the systems, highlighting various aspects of the design that you may want to be aware of or to improve upon if you want them to be resilient to future climate. At Airvag in the recent years, we also looked at the impact of these systems on CSO reduction. Typically, we use large CSO tanks, so we position CSO tanks along our sewer system in combined systems to prevent, to try and buffer the flows during heavy rain events and avoid spillage of raw sewage into receiving waters. And we found very interesting results from a study that one of our students, Prabhat, who's going to be joining ETH on a PhD very, very soon, that he undertook for his master's project. And that he showed that many different blue-green systems could potentially achieve similar comparable reductions in CSO spills, frequencies, and volumes at a reasonable cost, if not even more cost-effective way than your conventional tanks. But we, I think, also highlighted through that study that depending on the objective of the system and depending on the type of system you choose, different mechanisms will be at play. And each system will have these mechanisms at their disposal to deliver the number of different benefits that we want to achieve in our city. And so far, it's been about stormwater management benefits. But what about multifunctionality? So if we can deal with one objective, why not try and design these systems for multiple objectives? And when I say systems, I don't just mean your little widgets. Why don't you design a green space in particular for these multiple objectives? And so I did some interviews back in 2017, which I've been analyzing since. And I've also engaged a lot with stakeholders in 2017. And that helped me really understand the needs for multifunctionality and to build a so-called business case for these systems. There are different drivers depending on where you are, which city you're in, and therefore different priorities will take precedence. And so, whilst that may be the start towards designing these systems, eventually the challenge will all come back to the same list of objectives. So, you design a system for heat mitigation, but eventually you'll find that maybe stormwater management will start becoming more important. You design something for amenity and providing, areas of recreation, but you'll find eventually that they can actually serve as refuge during heat waves. And there's a lot of different stakeholders involved when you're talking about these different objectives and different organizations, and being able to come up with a solution that can, appease everyone is quite difficult, and you often have to make trade-offs. But there is definitely potential that these systems show to meet the objectives and the needs of a lot of different stakeholders. And so we need to be able to design them to do that. Furthermore, if you talk about the implementation aspect, councils, municipalities, water utilities, they treat these systems and these strategies as new assets and huge investments that need to be made. And they often compete with space with other facilities, whether it's, local municipal facilities or whether it's actually housing. And so being able to say, well, if we can put in a small space efficient system for multiple purposes, that is a huge cost benefit case for the people involved. It also aligns with this idea of needing to be more strategic about where we put these systems and how we design them, and less opportunistic. Analyzing a lot of the assets that we currently have and looking at the spatial arrangements, we see that a lot of these systems are very ad hoc. People just deliver them because it's nice to have, but they're not as aware of all the important objectives and the strategy involved in putting them in the right places. This was also confirmed talking to a lot of the stakeholders involved in the planning of blue-green infrastructure. Community stewardship is also becoming a more important aspect, and if people can see that many systems can provide all these different benefits, it awakens the interest in them to actually take on the leadership and the role to maintain them and to value them as well, similarly to how they would value a library or a playground. But the question is, how do we quantify and design these systems for multifunctionality? And I think a pet peeve that I've had, a pet hate that I've seen in the last few years is we've had all these different tools emerge, and we've even had a whole stream of reviews of these tools emerge in the literature. And I keep reading them over and over again. And the one recurring theme I keep seeing is that they're using very simple proxy indicators to try and make their argument for this multifunctionality. We have models across disciplines, and we have a solid understanding of how different processes across disciplines work. Why don't we explore them? And this is what I embarked upon when I started going much broader into the spatial planning. So there's three aspects I want to talk about today in more detail, one being urban amenity, the other one being the biodiversity aspect, and finally microclimate. In terms of the urban amenity, I really started at looking at how green spaces, which present, the infrastructure itself, the green infrastructure itself, because they themselves have roles to play in a city, but also the space available for putting in stormwater management or other kinds of systems. I looked at how these green spaces are arranged in cities. And when you start looking at different cities around the world with simple approaches like Euclidean distances, but also potential network connectivity of green spaces based on how close they are to each other, you start to see some very interesting trends in cities. Here's a comparison of Zurich and Melbourne, for example. And I've taken similar or areas with similar population sizes. Melbourne is much larger than what I'm showing. But here's a sort of a comparative area. And you can see that the green spaces, they vary completely in terms of the type of green space, but also where they're located, how clustered they are, and how the city or how the urban density fits within this area. And so we're trying to take this deeper and trying to see if we can use this to evoke the thought processes in stakeholders that we work with. One example is in Bern. So I've been working a lot with the Tiefbauamt in the city of Bern, and I've been mapping and doing lots of modeling of the area, the entire municipality. And this is an example of what the green space situation there looks like. And you can see from the initial modeling, and this is a very conceptual representation of it, but from the initial modeling, we can see, for example, that generally people live in close proximity to the green spaces. There are some pinch points, there are some locations where improvements could be desired. You can see where these red lines protrude. But overall, the city is doing not too bad, which is very reassuring for them. When they saw this picture, they actually thought that was very reassuring, in fact. A more interesting aspect is when I start looking at how we link up these green spaces. Once again, as I said, it's done based on a proximity distance. These are the kinds of pinch points that we start to notice. Well, generally, green spaces are connected around the city, but there could be ways to try and link up a lot more. Why is connectivity important? Well, for one, recreation. Bike paths, they present safe areas for people to do recreation in, and being able to pass through the city through the green areas provides more physiological, psychological benefits. These green spaces can also act as potential flood corridors, and they provide a lot of other amenity and in particular microclimate benefits. So that connectivity, in terms of the microclimate, you'll see later, it's also important for wind flow and being able to allow wind from the peri-urban areas to come in at night to cool the city. What's interesting is one particular aspect that they noticed just by looking at this map was it highlighted that the Stadtbach, which is currently underground, has potential to be daylighted and does lie at a particularly important pinch point within the city. And I actually learned through that process how there was talks about daylighting the creek in the past, but because of a lot of ownership issues and different stakeholders not really buying into this idea, the project was actually shelved. So it'll be interesting to see as I go further into this, engage more with the stakeholders, whether this particular discussion point comes up a lot more often, and hopefully it would be an opportunity to learn more about the planning decisions that they have been making in the past. Moving on to biodiversity. One aspect, and this is a project that we got through the Blue-Green Biodiversity Initiative between ERWAG and WSL, we've been looking at not just simply connecting areas together, but actually how you would connect up an urban landscape based on how animals move through it. And so we've been modeling the Zurich-Aargau region using a range of approaches, including trait analysis of amphibian species. The joke is that frogs are wet and dry, and Airwag and WSL are wet and dry, so therefore we would choose them. But we chose frogs because the data sets for frogs is quite abundant, and it would be a very nice way to, I guess, to start testing how the blue-green areas interact. The underlying concept is using circuit theory. So imagine we represent the area as an electric circuit, and urban areas will be resistances. And the more urbanized and the more dangerous the area is to species, the higher the resistance. This is a lot of the work that my postdoc that I've been co-supervising, Julia, has been doing. And she's been really showing through this approach that we can really start to identify key corridors through the entire landscape of what we call structural and functional connectivity. The subtle difference being functional is really the as is state, so based on where frogs are currently located, and the structural is the more general idea of how the landscape could be connected. But she's been doing a lot of this analysis with the amphibian species for the region. And when we start to zoom in to this map into the city area, we can start to see very interesting corridors in particular areas, particularly in Zurich-Uster. For example, along the Ziel, there's some very strong flow of current. So the output's actually electrical current. So it literally uses Ohm's law. We can start to see how this current flows along the Ziel area quite significantly, and where it sort of starts branching out. And this allows us to start saying, well, these are significant corridors, and understand why they're significant, whether it's increased greenery or whether there's certain unintended areas of refuge for species. But as we analyze this data, if we can then really start to understand why we're seeing high currents in certain areas, we can start to then design the landscape in a way that can improve biodiversity and enhance it in our city. And this connectivity then can then be improved for the sake of biodiversity conservation, which has been an ongoing threat and much more important aspect that's been highlighted globally as well. Finally, moving on to urban heat mitigation. This is work that João and I have been working on a lot. I guess that's why he's here, so it's glad to have him here. We've been looking at how these different systems, and there's a whole range of systems, greenery, water bodies features, hard surface like porous pavements or reflective surfaces, and practices as well, how they can mitigate urban heat. Urban heat is hot topic at the moment, no pun intended, well, actually pun well intended. But really the questions around it are, how do we actually support it? How do we support the mitigation of the heat? What is the effectiveness of different systems, the practicality, and once again, how do we actually make these systems multifunctional? So delivering the heat mitigation in addition to a few other aspects. And this is, we're in the midst of trying to revise a review that we submitted that really looks at a broad range of literature around these systems. And there's no real consensus about the effectiveness of these systems, but we certainly know that a lot of the concepts I've mentioned already, like connectivity and other aspects, they come into play. We've been looking at a particular microclimate model. It's a one-dimensional energy balance that can run at 10 to 30-minute time steps on a 30 by 30 meter grid. And it was developed in Melbourne by the guys at Monash and now Kerry Nice at Melbourne Uni. And I know they've worked with you guys on some microclimate work as well. So it was interesting to really see where the research, how the research sort of emerged. And this model target, it represents blue-green systems through land cover classification. It is driven by forcing data, so we need to use a regional air temperature, wind, and humidity measurement. But it's designed to be rapid, so there are obviously some limitations. For example, no horizontal advection, so it's a one-dimensional model. And the running joke is it is terrible at modeling deep water bodies, so our lakes show up as red. We like to call it the rivers from hell. And no anthropogenic heat is considered either. Fortunately, this work has also just been supported by the SNF under the Heat Down project, so we're extremely excited that it's gained traction as well. But what we've been doing is we've been looking at how we can apply targets to Switzerland, how we can adapt the model to Swiss conditions. to identify hotspots, potential impact on the population, but also its relationship with the blue-green coverage, as we say. And some mitigation solutions we're looking into include irrigation practices, the increase of vegetation cover, and the development of superblocks. So this idea of removing the roads and creating more pedestrian zones. One master student we had, she actually looked at how well this model performs in Zurich, and we actually tried to not calibrate, but we tried to see how well this model, with its base parameters that has been informed by the literature, performs in the Zurich region. And so we mined the NetAtmo private weather station network for this region in Zurich that you're seeing here, and to try to compare the actual temperatures measured by these systems with the model's results. Some examples, because it is a very spatial model, and so we've had I think there's 60 or 50 stations that we could get data from. Here's a snapshot of how the target model is actually performing compared to the measured data, and you can see from the looks of it, the red zone represents the span of temperatures measured by the private weather station, and then the model results, they run sort of within there. Modeling the system over 3-ish days really shows some interesting but really convincing and encouraging fits within the model. This really led us to pursue this much more heavily and to look at how we can use this model to actually support the planning. And so one aspect was really looking at the proportion of blue-green coverage within the different spatial zones within Zurich. And here it sort of shows we can really start to plot as the level of blue and green coverage increases. So from level 1, 0 to 20, up to level 5, almost 80 to 100% coverage, we can see how surface temperature variations will change across the city. And knowing these variations is also quite important because other factors, of course, are at play here. And quite importantly, for air temperatures as well. And air temperatures is something that I'm trying to push much more in the microclimate planning and assessment, because I've seen an overuse of surface temperature as an indicator where I feel it has a lot of limitations there. Apart from looking at the blue-green coverage, because this model is spatial, we can also start to really illustrate, well, how does this now actually look like if we start to trace transects from north to south or going through major areas? And this is just a plot of how target models the temperatures at different locations versus the pedestrian traffic that we sourced for inner Zurich. And you can see, based on the various locations that we chose, you'll find some very interesting examples, like the Bucheck-Platz, where there's a lot of greenery and lush vegetation, which then moves into Hofwiesenstraße. And there you see some fairly cool temperatures with high blue-green content. But you'll also get some potential areas where there's virtually no greenery. And showing this to planners, we feel, can really improve the awareness, but also allow us to be much more strategic with where to place these systems and how to design these systems. So that's really the urban heat mitigation aspect. One other aspect that's sort of happening in parallel in my collaboration with the University of Innsbruck is adding the human thermal comfort aspect to this whole story. And so a PhD student that I've been co-supervising, he's been looking at modeling the Universal Thermal Climate Index by mapping it from high-resolution color infrared images for the city of Innsbruck. And so now currently work in progress, but he's really delving deep into the relationship between the latent and the sensible heat fluxes within cities. And he's finding some very interesting relationships with the thermal comfort, but also how the surfaces and different urban forms will actually change the heat behavior, and bringing in much more the importance of water in the environment as well. So if you'd like to know more, feel free to get in touch and I can tell you a bit more about that too. So to sort of finish off, we've got all these disparate types of analyses, and they are based on a lot of the state of the art of their respective disciplines. And the question is, how do we put it together? And this is where Urban Beats, my dream and hope, as my plans are, this is where it comes back in, where we can take these different networks, these different maps that we define, and to really start doing this structured decision-making approach and structured analysis to identify where are our key corridors. And so with these different models that give us the fundamental basis for the analysis, we then try to integrate them into urban beats. And here's an example of how we've done it for Zurich. And to bring all the different aspects together, one more recent example is what I've been doing in the city of Bern, where we've really started to look at how water flows through the area, how the green spaces are connected and how close people live to them, what the temperatures look like within the city, and finally, what the connectivity for the amphibian species look like throughout the entire city. And putting this all together is basically, it's one of the biggest research questions that my major fellowship grants is going to be asking. So it'll be interesting to see how we go from here and how we start to use this data in a much more integrated way to then build actual solutions and identify the most crucial corridors that we need to be aware of. One other way that we're trying to put this together is also getting more involved in the practice of it, trying to bring it into practice through things like a design ideas competition. And I've sort of been involved with my postdoc, Julia, on the Gaswerk Areal in Brückenkopf West design ideas competition, which we're doing together with 2 architectural studios. And so it's been incredibly interesting because we were approached because of our ideas in the blue-green space. And we've been sort of supporting their design process and teaching them about the importance of the different aspects, the microclimate, the biodiversity, the green space connectivity, as well as the urban stormwater management. And that competition submission is actually due tomorrow, so it's very exciting to see what the final outcome is going to be. Architects make incredible drawings and incredible illustrations, so I'm really intrigued. But we've supported them in a number of different ways with a number of different analyses. Just to give you an insight into all the different aspects, we've looked at the park's connectivity. I've done some modeling with the microclimate, surface and air temperatures, daytime and nighttime. Julia's looked at the functional connectivity of amphibians' passages through Bern and trying to see what this site represents in terms of the connectivity. We've looked at the hydrology, we've looked at the topography, and I've even looked at different strategies for sizing rainwater harvesting tanks to try and maintain the green spaces on site, yielding very different sizes depending on the reliability you want of the system. So 2 different approaches to try and bring this all together, one being the more research-based approach, and the other one being the more practice and engagement-based approach. But the question is where to from here? And this is where my Blue Green Alive project comes in, which I've submitted as an Excellenza to the SNF, as well as a starting grant to the ERC. So I devised a project that really involves the international collaboration network that I've had. So it'll be based with you guys, and it'll be really cool if I get it. I haven't heard anything yet, but let's keep our fingers crossed. It'll feature 5 international case studies. So it's really trying to test these ideas across the globe to make sure that they are transferable, that we're aware of the different solutions in different climate regions and city types. But this is where we really try to bring a lot of this knowledge together to then plan and decide how to transition towards a blue-green city. So not just how we design the systems, but can we actually design policy to actually drive, the adoption of these kinds of systems. And we plan to use urban modeling and urban dynamics to try and add that added bit of richness to the project. Huge collaborator network, and I'm incredibly happy that they supported this project as well. So let's see if it's successful. Either way, key takeaways really from this talk, and really my current mindset is blue-green systems. It's highly interdisciplinary, and we're not going to avoid that. But we also need rigorous approaches across these disciplines. I've seen so many simplistic ways of going about it, and I think it's time we really delve deep and we really collaborate across the disciplines to deliver rigorous approaches. It's not just about technologies. I think we understand a lot about it, but we need to look a lot into the spatial planning. If you read up about green infrastructure, especially in the UK and the US, it's actually a lot more focused on green spaces and planning of the urban space rather than an actual technology. They're synergistic and they contribute differently to the various benefits of ecosystem services. We still need advancements in the modeling and the geospatial approaches to better support the planning. But I think a key question that is always on my mind is how do we best balance the policy, the practices, the spatial planning, and then finally the technologies to complement all of that. So I hope that whet your appetite a bit for a lot of the work that I've been doing. So with that, thanks a lot. And if you want to reach me, my email's there, my websites are there, and you can view more of my work at my YouTube channel as well. So thanks a lot.